Okay, today we will understand what is isochromatic HPLC analysis, and we will also try to understand the disadvantages and advantages of isochromatic analysis. Okay, when the composition of mobile phase does not change during analysis, the method is said to be isochromatic. It means, suppose we are making a mobile phase of fixed composition 70 is to 30 of buffer, and for example ACN as an organic phase, and it is having a flow rate of 1 ml per minute. Now what will happen when we run the method? The mobile phase, which is of fixed composition of 70 to 30 of buffer and ACN, it will flow at 1 ml per minute through the column at a constant rate throughout the analysis. Now what is happening here? The mobile phase composition is not changing. It is remaining constant throughout the analysis, and thus this method is called isochromatic. And the reverse of this process, where the mobile phase composition is changing during the analysis, will be called as gradient mode of analysis. So now we are focusing here on isochromatic analysis. After this we will come to the disadvantages and advantages of isochromatic analysis. First we will focus on disadvantages of this isochromatic mode of analysis. Now what will be the disadvantages of this isochromatic analysis will become the advantages of gradient mode of analysis. So the first is poor resolution of early eluting peaks. It means when we are having more than 2, 3, 4 or 5 peaks in any method, it is especially in the case of relative substance method where we are having many peaks of impurities. Now what is happening in this, more than one peak may be having the same elution power or same polarity in the case, so they will elute at the same RT or may elute at the void volume, so the resolution between these peaks is decreased. So in this isochromatic mode of analysis we don't have any advantages of changing the mobile phase composition, so the resolution between the peaks is decreased. Now this poor resolution where we have problem or the limitation where we cannot change the mobile phase composition becomes an advantages for gradient mode of analysis, where we can change the mobile phase composition and increase or decrease the resolution as we want for the impurities or for the peaks which we are going to analyze. The second is increase in peak width and decrease in peak height of later eluting peaks. Now what happens, the later eluting peaks in the case of isochromatic analysis, which peaks will get later elute? It means जो peaks हमारे कॉलम के साथ ज़्यादा बाइंड कर जाएंगी, ज़्यादा रिटेन कर जाएंगी, तो उनका जो रिटेंशन टाइम है वो इंक्रीज हो जाएगा, एंड विद इंक्रीज इन रिटेंशन टाइम द विड्थ ऑफ द पीक decreases and height is also decreased. So this is the disadvantage of isochromatic mode of analysis. Now with this increase in width and height due to the retention, due to the increased retention of peaks or due to the more binding of peaks to the column, it also increases the analysis time of our method. So this is also one disadvantages associated with this isochromatic mode of analysis. The last is the column contamination by strongly retained component. Now sometimes it happens that many peaks or compound is strongly retained with the column in the isochromatic mode of analysis, and because of this it will, the peak width will increase, the decrease it will, the height of the peak will decrease, and sometimes it happens that it retain on the column, and when we perform some next analysis on the same column, cross contamination of that product can occur. So these are some of the disadvantages which are isocratic associated with isochromatic mode of analysis, which can be rectified by using gradient mode of analysis. So we have to focus on these disadvantages, that what are the disadvantages of this isochromatic mode of analysis which can be overcome by gradient mode of analysis. Now after this we will come to the advantages of this isochromatic mode of analysis. Now in case of assay and dissolution test, where we have only the single peak of interest, means in dissolution or assay we focus only on mainly on the single peak, so isocratic mode of analysis here becomes an advantage. Why? Here we can fix the composition of our mobile phase during the development process, and it becomes easier for to elute only a single peak in the case of assay dissolution. Now it becomes problem when there are more than 1, 2 or 3 or peaks, so isocratic mode there does not works properly as compared to the gradient elution. And second is, it is also considered to be cost effective method, because in gradient mode of analysis during the development time or during the routine analysis, here more organic solvents, more buffer is consumed as compared to this isocratic mode of analysis. So these are the advantages and disadvantages of this isocratic mode of analysis. Hope you have got an idea what is isocratic mode of analysis and what are its disadvantages and advantages. If you have any confusion or you want to add something add in this video, you can comment me in the comment section. All your comments and suggestions are welcome. So thank you for now. We will meet in our next video.